All right, welcome back to part 2 of this peer review. For all the people that are criticizing out there, so for one, this book is freely available online. Terrence Howard put it out there. He wants people to read it. Terrence Howard has come out and said he wants people to learn about his ideas. That's why he goes on these podcasts and stuff. He's issued challenges saying, "Oh, if you can disprove me, or if you can come up with a better theory than mine, then go for it." So the only way that we can hope to come up with a better theory than Terrence Howard's is to read his theory. 2, definitely not going to get into like the entirety of this book. I wanted to look at some of the mathematical things. That's more of my priority here. This is not bullying in any way. It's not. If I happen to laugh out loud, it's because it's something that's just I couldn't help it at the moment. I have read through this before, but it's been a while since I've done that, and so again, pardon me if I laugh out loud sometimes. It's difficult not to. If that's something that's going to bother you, then don't watch this video. Today what we're going to do is we're going to go through the first page. Or the first 2 pages. I'm not sure what you consider this to be. Interestingly enough, I've actually been on a textbook adoption committee before, where we had to read through a few selections of textbooks and decide which one we wanted to implement into our curriculum at the district that I was at the time. I've contributed to textbooks before, so I do have some experience with proofreading and with, seeing if it's up to snuff. And we can kind of look at it from that approach then. It's like, instead of you viewing this like it's me bullying or being mean to Terrence, remember, I'm just providing my expert opinion here. Because who knows, maybe Terrence might want this book to be taught in schools. And I think there's some value to it, especially in pointing out things that are wrong with it. Or I should say, the only value it has, I think, is in pointing out what's wrong with it. But that's pretty interesting. I'm pretty interested in that. I'm really into math. I'm really into education. So I like analyzing math and seeing what's going on. He wrote this as a book. I'm not sure if it's supposed to be a textbook, but he put it out there for us to read, so let's read it. Let's give him the chance to wow us and do our due diligence in peer review. First of all, great start to the book. Allow me to enlighten you. All right, we're ready to be enlightened. If, big if, 4/2 is the inverse operation of 2 times 2 equals 4, then it would naturally follow that 2/1 is the inverse operation of 1 times 1 equals 2. A few things already wrong with that. Let's highlight. 4/2 is what we call a mathematical expression, whereas 2 times 2 equals 4 is what's known as an equation. So an expression here cannot be the inverse operation or the inverse anything of an expression. When you rearrange something like 2 times 2 equals 4 and make it into a division problem, let's get rid of the word operation because that's not what's happening here. 2 times 2 equals 4, the inverse would probably look something like 4/2 equals 2, or 4 divided by 2. You know what, let's use his notation. So he goes 4 divided by 2 equals 2. That might be the inverse that he's talking about. This is missing an equal sign. That would naturally follow that 2/1 is the inverse operation of 1 times 1 equals 2. Let's circle that. That's also an expression, not an equation. So it can't be linked to an equation in any way because there's no equal sign. It's missing a crucial part of information. There's 3. Okay, he knows how to count, right? There's 3 quantities right there. 2, 2, 4. There's only 2 quantities over here. 4, 2. So he's making it ambiguous then. It's not clear how this is a rearrangement of that. So 2 over 1, he says, is the inverse operation of 1 times 1 equals 2. Again, let's not say operation because that's not the right word. Of 1 times 1 equals 2. So, okay, so he's not saying what this is equal to. 2 divided by 1 is equal to 2. That's not the inverse of this. It would be the inverse of 1 times 2 equals 2, or possibly 2 times 1 equals 2. If he were to actually finish this out over here and say, okay, yeah, 2 over 1 equals 2. He never finishes this. He says 4, so 4 divided by 2. He doesn't even say what that equals. I'm assuming he's saying it equals 2. Naturally follow, I don't know if he's read that somewhere, but this does not naturally follow. He's not using that correctly here, logically. What does your common sense tell you about the two scenarios? What do they have in common and what are their differences? So again, what they have in common is that you cannot, that one's an expression, one's an equation, so you can't do that. Let's just move on from this because it's just, ugh. Division. The number 4 is divided by 2 twice. What? That's it. And the truth is the number 2 is divided by 1 twice. Okay, so he calls that division, even though it's written in words, and the other stuff's written in equations, which was an odd choice. 2 plus 2 equals 4, and 1 plus 1 equals 2. Why is he doing this? What's happening here? What's going on? Because, okay. So once again, these are equations, okay, right? Can we all agree on that? These are equations. Whenever he's doing up here, he says the number 4 is divided by 2 twice. That's not an equation. It doesn't say what it's equal to. He just says, okay, you divided number 4 divided by 2 twice, which is 4 divided by 2, which gives you 2, and then you divide it by 2 twice, so divided by 2 again gives you 1. So that would, maybe he meant to say equals 1, right? The truth is the number 2 is divided by 1 twice. Wait, what? Why would you divide by 1 twice? Are you, well, the number 2 is divided by 1 twice. So the number 2 gets divided by 1, which leaves it as 2. Then it gets divided by 1 again, which gives you 2. So these two aren't even equal. God, it's so difficult to figure out what is happening here. What's he doing? Why is he doing this? So, okay, so I'm really, okay, I got a big question mark here about division. I don't know what's going on there with division. But you know what? It kind of does make sense because when you go back up here, it says, okay, it says 4 divided by 2. That's the number 4 is divided by 2 once, or twice. Why does he say twice? Oh, okay, wait. So wait, is this going? No, that doesn't, okay. 2 plus 2 equals 4. What is, and 1 plus 1 equals 2. I was saying it kind of makes sense that his division is not complete. It doesn't say what it is equal to because these ones that I've circled here also don't say what they're equal to. Although he's kind of saying that they're the inverse expression or inverse equation. I would not use the word operation. It doesn't make any sense. You think about inverse operations. What does that mean? It just means that plus is the inverse of minus. Minus is the inverse of plus. That times is the inverse of divided by. Divided by is the inverse of times. That's what inverse operation means. Pardon the handwriting. So, it's really difficult to tell what's happening here. 2 plus 2 equals 4, 1 plus 1 equals 2. Okay, I agree with those. That's fine. Subtraction. You know what this reminds me of? They used to call them fact families. And I had to kind of rack my brain to think about that for a second because I was trying to remember when my son was in like second grade. I've never taught second grade. I've never taught third grade, but they used to give them like, a fact family sheet, and it would be kind of like, okay, if 2 plus 2 is 4, that means 4 minus 2 equals 2. It's just a way of rearranging stuff. It gets kids more used to rearranging stuff algebraically, which is cool. This, I don't know where he's going with this, because 2 plus 2 equals 4, and 1 plus 1 equals 2. Okay. Subtraction, 4 minus 2 equals 2. So that would be in the same fact family, I think, as 2 plus 2 equals 4, right? That actually is rearranged. When you go from here to here, so that's successfully rearranged. That's cool. Good job. Let's put a little happy face. And 1 plus 1 equals 2. That's also correct. 2 smiley faces. Subtraction. Okay, this is rearranged, right? 4 minus 2 equals 2. 1 plus 1 equals 2 is rearranged as 2 minus 1 equals 1. That's correct. So these are, again, rearranged. This 2 is over here. This 1's... See, you could tell that it's because you have what's actually called a bijective function between these two things. You have 1 goes in one spot and 1 goes to another spot. That actually, you can tell what he's doing there. Okay, multiplication. 2 times 2 equals 4 and 1 times 1 equals 1 is correct. He's got like a little magnifying glass here. I'm not really sure why. 2 times 2 equals 4 is right. 1 times 1 equals 1 is also correct. But was that in reference to what's been going on so far? Like this 1 right here? Because 4 divided by 2. It would naturally follow that 2 over 1. 1 times 1 equals 2. Again, that doesn't make sense. Let's put another question mark here, I guess. What do they have in common? What are their differences? Again, when he says division, this is one of the most confusing things I've ever seen. Because what's he talking about? He's just putting it into words, but he's never saying what these are equal to. He's saying the number 4 is divided by 2 twice. I'm not sure why it's twice. Why is it twice? Is he saying going from here to here? So 4 is divided by 2, then it's divided by... No, this is divided by 1. So that doesn't even make sense. Yeah, this says 4 divided by 2. If this had another divided by 2, if this were a divided by... If this said 2 divided by 2 to get 1, if this were a 2, that would make more sense. And he says the truth is the number 2 is divided by 1. I'm sorry, I can't help but laugh at that. It's divided by 1 twice. Twice. Why? Where is it divided by 1? What is that? Because here you're dividing 4 by 2, then you divide 2 by 1. He's saying that the number 2 is divided by 1 twice. So again, divided by 1 twice is a weird thing to say because when you divide by 1, it doesn't change a number. So I don't know why you would bother doing it twice. His little fact families here are pretty cool. He's got a magnifying glass here. Let's see what he said. Can you see where the mistake has occurred? Both of these scenarios are identical in every way. Wait, what? Both scenarios? He's saying 4 divided by 2 is the inverse of 2 times 2 equals 4. He's saying that's identical to 2 over 1 is the inverse of 1 times 1 equals 2. What's not? What did he do here? Did he just divide everything by 2? Hold on. Let's erase some of this. So, hold on. Did he do this? Did he just divide everything by 2? Because if you do that, you get this 4, okay, it becomes a 4 divided by 2 is 2. 2 divided by 2 is 1. 2, there's a 2 here, yeah. Yeah, that's what he did. Okay, we figured it out. He took this original thing under the if, he divided everything by 2 to get down to this. It would naturally follow that statement. Okay, so, okay. This is completely invalid. First of all, you can't just go around dividing by 2. Over here, it's fine, like, because you have an equal sign. You have 2 times 2 on the left, so divide by 2 on the left, divide by 2 on the right. And the reason why I wrote divided by 2 3 times is really because that's probably how he's viewing it. We're not dividing by... Okay, wait. I think I figured something out here. Hold on. Because he's saying divided by 2 twice. The number 4 is divided by 2 twice. The number 2 is divided by 1 twice. So, okay. Again, if you have... I can erase this. Because it's not... you really are just dividing by 2 once. Because you're dividing... If you do times 2 divided by 2, these 2 cancel out. So then you have that. What's going on? So that would cancel out. That would be like, okay, then you have 2 equals 2. Which is true, which is fine, which is cool. Cool. Then you've got, okay, so then he's dividing by 2 over here. There's no equal sign over here, so it's difficult to see what he's trying to do there. There's no equal sign. So yeah, you can divide the numerator and the denominator both by 2, and you get a simplified version of that fraction. That's true. You could say that 4, let's see. Should I switch colors? I know he likes red. Let's go to 4 over 2 is equivalent to 2 over 1. That's correct. These 2 are the same. Although it doesn't say what they equal, because 4 divided by 2 is 2, and 2 over 1 is also 2. Yeah. 4 divided by 2 is 2. 2 over 1 is also 2. I guess he's thinking because he can do that over here, what I've shown in purple, that he can do the same, that he can apply the same logic to that over here, even though he's not applying the same logic. He's saying, oh, if I divide everything here by 2, then I can get 1 times 1 equals 2. But he's not dividing everything by 2. He's dividing, but that's not. Wow. This is such a terrible start to the book. Can you see where the mistake occurred? Yeah, can I see where the mistake occurred? Yeah. Yep. Definitely. Both of these scenarios are identical in every way. The only difference exists in dimension alone. If they add, subtract, and divide according to the same ratio, then they must also multiply according to the same ratio. What does that mean? The same ratio? So usually when we say ratio, we're referring to a division. If you have 2 things in a ratio, you divide them, you get, it's a ratio. Fraction, decimal, percentage, all the same thing. Plain and simple. This is the opposite of plain and simple. Let's be real here. So if 2 over 1 is inconsistent with 1 times 1 equals 1, what? Although 4 over 2 is consistent with 2 times 2 equals 4, then it should follow that 2 squared equals 4 and 1 squared equals 2. So he starts the book off strong. He starts this book off strong with some really bad logic. He says if and although and then, and he's making these outrageous claims that really don't make any sense. Yet the math and scientific community tells us that common sense and logic are wrong in this case because of a product of an arbitrary convention called the identity property. But he does not like the identity property. He's not a fan of it. he doesn't understand it. He doesn't understand why multiplying by 1 just leaves things unchanged. So what's up with this statement? If 2 over 1 is inconsistent with 1 times 1 equals 1. Again, let's spell it out now. This is an expression. These are expressions. And this is an equation. These are equations. So he can't have an equation and an expression have some sort of equivalence. Definitely not what I would call an inverse operation or inverse relationship or anything like that. It should follow that 2 squared equals 4. Now, I don't know where you're getting that. It should follow that. And then 1 squared equals 2. But that's not even, this does not make sense. So 2 over 1, where did he say that 2 over 1 is inconsistent with 1 times 1 equals 1? Because of the magnifying glass? It naturally follows that 2 over 1 is the inverse operation of 1 times 1 equals 2. So he's saying that, okay, he's put this 2 over here. He's trying to say that that's this 2. The thing is, what's confusing about this, and the reason why I point out that one's an expression and one's an equation, is because it's a little ambiguous. Here, like I said before, let's just count it out, because right here you have 1, 2 numbers. Over here you have 1, 2, 3 numbers. So it's difficult to tell. Let's use his second one, I guess. If you have 4 over 2, 4 divided by 2, and you're trying to compare that with 2 times 2 equals 4, there's an ambiguity here of this 2. It's like, is this 2 the same as this 2? Or is this 2 matching up with this 2? There's an ambiguity. It doesn't make any sense. So, and again, so he's saying because this is inconsistent, because this left side's inconsistent with the right side, that means that the 1 squared has to be equal to 2? Why? That doesn't logically follow. This doesn't make sense. By the way, if you're wondering what the identity property is, it's the notion that anything times 1 is equal to itself. I think one of the biggest issues he's having here is that he seems to think that this equation and this equation are related somehow. That if you do 2 times 2 equals 4, you can use 1 times 1 equals 2, you can kind of scale it up, you know what I mean? Like, he seems to think that if you have 1 times 1 equals 2, then you could like scale it up somehow by multiplying every single part of it by 2. But he goes times 2. He does times 2 to everything, right? So he multiplies this 1 times 2, then this 1 times 2, then this 2 times 2. If you do that, you get 2 times 2 equals 4. And then he looks at that and he was like, well, that's true, that's valid. So it must mean that the original assumption there, 1 times 1 equals 2, is correct. What he doesn't realize that he's doing here is that he's actually multiplying too many times. He's been multiplying by 4 on the left side, where he's multiplying by 2 on the right side. Because he's multiplying every single number times 2. So again, this is multiplied by 4 times 2 times 2. This is multiplied only by 2. So it's not balanced. He's not balancing equations. He doesn't know how to balance an equation. I think that's at the root of a lot of his issues here. Another thing I'm noticing, I think he's got some misconceptions about the fact that 2 plus 2 equals 4 and 2 times 2 equals 4 are not just a coincidence. Again, maybe that's the wrong word, but let me scroll down and get some room here. So, you consider something like 2 plus 2 equals 4. That's true. 2 times 2 is also equal to 4. And that can make addition and multiplication confusing to certain people because 2, well, besides the number 0, 2 is the only number that this happens for. It's the only number where if you add it to itself, it's equal to when you multiply it by itself. So 2 plus 2 is equal to 2 times 2. But because that's the case, right, that's an instance of this occurring, it doesn't mean that it's always the case. So that does not imply that a plus a is always equal to a times a. If we get a little more general with it. It doesn't mean that there's an infinite number of solutions here for a. In fact, there's only 2 solutions for a, and that is that a is equal to 0, or that a could be equal to positive 2. Indeed, those are the 2 solutions for this equation right here. The proof of which is left as an exercise for the viewer. So anyway, that's a little bit of my analysis as far as exactly what's going on. I think at the heart of everything is confusing multiplication and addition. It's obvious here that he's conflating these two. The 2 plus 2 being the 2 times 2. He thinks that those are the same thing, or he thinks that that is some sort of universal law. But in fact, 2 is the only number besides 0 that actually works for. So hopefully that makes his misconceptions make more sense. I think it does. Again, kind of summarize it by he's incorrectly scaling 1 times 1 equals 2 into 2 times 2 equals 4. He doesn't realize that he's dividing or multiplying too many times. He's confusing addition and multiplication. Again, I'm not sure why he's using words here and then equations here. And then again, I think one of his big other misconceptions is he thinks that 2 plus 2 equals 4 has something at all to do with 2 times 2 equals 4. And it doesn't. It's not, again, to use a term that I used before, it's not in the same fact family. It's pretty much just a coincidence. All right, so if you enjoyed that mathematical breakdown, please like and subscribe. My plan was to deep dive into this more over the summer, and I guess, I don't know, basically if I get bored. Because it's interesting. It's actually really interesting to me, and I don't mean to just go around laughing at him and stuff. I just can't help it sometimes because it's funny. Anyway, good luck to everyone. Please like, comment, and subscribe. More videos coming this summer, or you can check out my other channel, which has a bunch of old math content, and I plan to actually update that with more math and computer science stuff this summer. Thanks a lot.